Students of grade 3 secondary, welcome to our math program. Today we have calculus. Our lesson today is the two equations of a tangent and the normal to a curve. If we have a curve of a function y equals f of x, and we need to find the equation of the tangent and the normal by using the first derivative to get the slope of the tangent and the normal to a curve. Y equals f of x is a curve, and we draw the tangent and the normal to the curve at a given point x1 and f of x1. Then the slope of the tangent of the function, or the slope of the curve of the function y equals f of x at the point x1, y1, which is lying on the curve, is dy dx at x1 and x and y1. Thus, the slope of the function or the slope of the normal to the curve of the function y equal f of x at the same point x1 and y1, which is lying on the curve, is -1 over dy dx at the same point x1 and y1. Now, what is the equation of the tangent and the equation of the normal to a curve? Let we have a point x1, y1 be any point on the curve of the function y equals f of x, and the slope of the tangent to the given point is m, which equals dy dx at this point x1 and y1. Then the equation of the tangent at the point x1 and y1 is y minus y1 equals m times x minus x1, or y minus y1 equals dy dx at the point x1 and y1 times x minus x1. We know that the slope of the tangent is the first derivative of the function at the point x1 and y1. Now, let the point x1, y1 be any point on the curve y equals f of x, and the slope of the normal to the given point is m equals -1 over dy dx at x1 and y1, -1 over the first derivative of the function at the point x1 and y1. Then the equation of the normal at the point x1 and y1 is y minus y1 equals -1 over m times x minus x1. In the other meaning, y minus y1 equals -1 over dy dx at the same point x1, y1 multiply x minus x1. Let's start with the first example. Find the two equations of the tangent and the normal to the curve x power 2 plus 3xy plus y power 2 plus 1 equals 0 at the point -1 and 1, which lies on it. Now we have relation between x and y, the relation x power 2 plus 3xy plus y power 2 plus 1 equals 0, which is the equation of a curve. By differentiating both sides with respect to the variable x, then we get the derivative of x power 2 is 2x plus 3 multiply the derivative of x times y is y plus x dy dx plus the derivative of y power 2 is 2y dy dx, and the derivative of the constant number 1 equals 0, then 2x plus 3y plus x dy dx plus 2y dy dx equal 0. By simplify, 2x plus 3y plus 3x dy dx plus 2y dy dx. Then 2x plus 3y plus, by taking dy dx as a common factor, then between two brackets 3x plus 2y multiply dy dx equal 0. 3x plus 2y times dy dx equals negative 2x minus 3y. Then the slope of the tangent of the curve at any point equals dy dx. Then dy dx equals negative 2x minus 3y over 3x plus 2y, which is the slope of the tangent of the curve at any point on the curve. Now, dy dx at the given point, which is negative 1 and 1, equals negative 2 multiply negative 1 minus 3 multiply 1 all over 3 multiply negative 1 plus 2 multiply 1. Then the slope of the tangent equals 1. What is the equation of the tangent? The equation of the tangent is y minus y1 equals m multiply x minus x1. Then y minus 1 equals the slope of the tangent, which equals 1, multiply x minus negative 1. Then y minus 1 equals x plus 1, and y equals x plus 2 is the equation of the tangent at the point negative 1 and 1. Now, the slope of the normal. The slope of the normal equals negative 1 over the slope of the tangent. Then, the slope of the normal equals negative 1. What is the equation of the normal at the point negative 1 and 1? Yes, y minus y1 equals negative 1 over m, which is the slope of the normal, multiply x minus x1. Then y minus 1 equals negative 1 multiply x minus negative 1. Then y minus 1 equals negative x plus 1. Then y equals negative x, which is the equation of the normal at this point. Another example. Find the two equations of the tangent and the normal to the curve x equal t power 2 plus 4t, y equals 2t power 2 at t equals 1. Now, we have a parametric relation. X equals t power 2 plus 4t, then dx dt equals derivative of t power 2, which is 2t, plus derivative of 4t, which equals 4. Then dx dt equals 2t plus 4. And we have y equals 2t power 2. Then dy dt equals 4t. We know that dy dx equals dy dt multiply dt dx, or dy dt divided dx dt. Then the slope of the tangent of the curve at any point equals dy dx. dy by dx equals 4t divided 2t plus 4. We can simplify the expression, then dy dx equals 2t over t plus 2. Then, what is the slope at t equals 1? dy dx at t equals 1 equals 2 multiply 1 over 1 plus 2. Then dy dx at t equals 1 equals 2 over 3. Now we have the slope of the tangent at t equals 1. Now, what is the point lying on the curve x, y? The point at t equals 1 is x equals t power 2 plus 4t, which equals 5, and y equals 2t power 2 at t equal 1, then y equals 2, then the point is 5 and 2. Now, we have the slope of the tangent equals 2 over 3, and the point is 5 and 2. Then the equation of the tangent is y minus 2 equals 2 over 3 multiply x minus 5. Then 3y minus 6 equals 2x minus 10. And we can get the relation 3y minus 2x plus 4 equals 0, or 2x minus 3y minus 4 equals 0. This is the equation of the tangent of the curve at t equals 1. Now, what about the slope of the normal? We know that the slope of the tangent equals 2 over 3, then the slope of the normal equals negative 3 over 2. Then, the equation of the normal at the point 5 and 2 is y minus 2 equals negative 3 over 2 multiply x minus 5. Then 2y minus 4 equals negative 3x plus 15, and 2y plus 3x minus 19 equals 0. Then the equation of the normal is 3x plus 2y minus 19 equal 0. Now we move to the next example. Find the two equations of the tangent and the normal to the curve y equals 2x minus cotan x at point which lies on the curve and its x coordinate equals pi over 4. To find a point lying on the curve when x equals pi over 4, we calculate its y coordinate. We know that y equals 2x minus cotan x at x equals pi over 4, then y equals 2 multiply pi over 4 minus cotan pi over 4. We know that cotan pi over 4 equals cotan 45, which equals 1. Then y equals pi over 2 minus 1. Then the point of tangency is pi over 4 and pi over 2 minus 1. Now we have a point and we want to get the slope. The slope of the tangent of the curve at any point lies on it equals dy by dx. You know that y equals 2x minus cotan x, then dy dx equals the derivative of 2x equals 2 minus the derivative of the trigonometric functions cotan x is negative cosec power 2x. Then dy dx equals 2 plus cosec power 2x. Now, what is the slope of the tangent at the points pi over 4 and pi over 2 minus 1? We can, substituting in the slope of the function, which is 2 plus cosec power 2x, at the point pi over 4 and pi over 2 minus 1, then dy dx equals 2 plus cosec power 2 pi over 4, then dy dx at the point pi over 4 and pi over 2 minus 1 equals 4. Now we have the slope of the tangent equals 4 and the point is pi over 4 and pi over 2 minus 1. Then the equation of the tangent is y minus y1 equals m times x minus x1. y equals y minus, between two brackets, the y coordinate of the point, which is pi over 2 minus 1, equals 4 multiply x minus pi over 4. Now, y minus pi over 2 plus 1 equals 4x minus 4 times pi over 4, which equals pi. Then y equals 4x minus pi over 2 minus 1, which is the equation of the tangent at the point pi over 4 and pi over 2 minus 1. Now, the slope of the normal. We know that the slope of the tangent equals positive 4. Then the slope of the normal equals negative 1 over 4. And the equation of the normal is y minus y1 equals negative 1 over 4 times x minus x1. Then y minus, between two brackets, pi over 2 minus 1 equals negative 1 over 4 multiply between two brackets x minus pi over 4. Multiply both sides by 4, then 4y minus 2 pi plus 1 times 4 equals 4 equals negative x plus pi over 4. Then 4y equals negative x plus pi over 4 plus 2 pi minus 4. Pi over 4 plus 2 pi, which equals 9 pi over 4. Then 4y equals negative x plus 9 pi over 4 minus 4. And we can divide both sides by 4. Then y equals negative quarter x plus 9 over 16 pi minus 1, which is the equation of the normal at the point pi over 4 and pi over 2 minus 1. Now we move to the next example. Find the points on the curve y equals x power 2 minus 4x plus 3, at which the tangent to the curve, number 1, parallel to x-axis, number 2, parallel to the straight line y minus 2x plus 3 equals 0, number 3, perpendicular to the straight line 6y minus 3x minus 5 equals 0. Now we have y equals x power 2 minus 4x plus 3 is the equation of a curve, quadratic function. We know this function y equal x power 2 minus 4x power 3 have a tangent parallel to x-axis. Now we want to get the first derivative or dy by dx for this function, which equals 2x minus 4. Now we have the slope of the tangent at any point on the curve of the function y equal x power 2 minus 4x plus 3. Now, number 1, the tangent is parallel to x-axis. Then dy dx equal 0. Because the slope of any straight line parallel to x-axis equals the slope of the x-axis. What is the slope of the x-axis? The slope of the x-axis equals 0. Then dy by dx equals 0, and we get the equation 2x minus 4 equal 0. Then 2x equals 4 and x equals 2. What is the y coordinate of this point? By substituting in the function y equal x power 2 minus 4x plus 3, we get y equals 2 power 2 minus 4 times 2 plus 3. Then y equals negative 1. Then the point is 2 and negative 1. Now the second required. The tangent is parallel to the straight line y minus 2x plus 3 equals 0. We know that the slope of the straight line equals negative coefficient of x over coefficient of y. Then the slope of the straight line y minus 2x plus 3 equals 0 is negative 2, which is the coefficient of x, over 1, which is the coefficient of y. Then the slope equals negative 2 over 1 equals 2. And we have the slope of the tangent equals 2x minus 4 at any point. Then 2x minus 4 equals the slope of the straight line, which equals 2. Then 2x equals 2 plus 4 equals 6. Then the x coordinate if the point of tangency equals 3. What is the value of the y coordinate? We can substitute in the original equation. Y equals x power 2 minus 4x plus 3 to get y equals 3 power 2 minus 4 multiply 3 plus 3. Then y equal 0. Then the point is 3 and 0. The point of tangency, which is a straight line y minus 2x plus 3 equals 0, parallel to the tangent to the curve. What about the third required? The third required, the tangent is perpendicular to the straight line 6y minus 3x minus 5 equal 0. Now, what is the slope of the given straight line? Negative coefficient of x over coefficient of y. Then the slope equals negative 3 over 6, which equals half. Now, we have the slope of the straight line. And we know that the tangent perpendicular to the straight line. Then the slope of the normal equals negative 2. Because the slope of the tangent multiply the slope of the normal equals negative 1. Now, 2x minus 4 equals negative 2. Then 2x equals positive 2. Divided both sides by 2. Then x equals 1. What is the value of y coordinate of this point? We can substitute in the original equation. Y equal x power 2 minus 4x plus 3. Then y equals 1 power 2 minus 4 multiply 1 plus 3. Then y equals 0. And in this case, the point is 1 and 0. Another example. The measure of the angle which is a tangent to the curve sine 2x equals tan y makes with the positive direction of x-axis at the point 3 pi over 4 and 3 pi over 4 lying on it equals 0, equals 135 degrees, equals 45 degrees, or equals 26 degree 34 minutes. Now we have trigonometric functions. Sine 2x equals tan y, the equation of a curve. By differentiating both sides with respect to the variable x, then the derivative of sine 2x is cosine 2x multiply 2. Then the derivative of sine 2x is 2 cosine 2x equals the derivative of tan y. Derivative of tan y is sec power 2y dy dx. Then 2 cosine 2x equals sec power 2y dy dx. At the point 3 pi over 4 and 3 pi over 4. Then 2x 2 cosine 2x, which equals 2 cosine 3 pi over 2 equals sec power 2 y. Y equals 3 pi over 4. Then sec power 2 3 pi over 4 multiply dy dx. Now, by using your calculator, cosine 3 pi over 2 equals 0. Then the left hand side equals 0. And sec power 2 3 pi over 4 equals 2 multiply dy dx. Then dy dx equal 0. The slope of the tangent to the curve sine 2x equals tan y at the point 3 pi over 4 and 3 pi over 4 equals 0. And we know that the slope equals the tangent or the tan of the angle which is a tangent to the curve makes with the positive direction of x-axis. Then tan theta equals 0. Then the measure of the angle theta equals 0 degree. And by this example, we come to the end of our program today. Till we meet again, it's goodbye.